You see that? Insulin dependent. Doesn't sugar gives you fat though? No, sugar does not give you fat. Sugar stores up in the liver and the liver turns sugar into fat. But again, that's good sugar. It's called glycagon. It stores up in the liver. And what happens is, the reason why it stores up in the liver, for when you need sugar or fuel, what happens is this glycagon that was stored up into fat by the liver turns back into sugar and then gives you ATP. This is a different type of fatty acid and a lipid that I'm talking about. So sugar do not turn into fat. The liver converts sugar into fat and hides it in the liver, for it's basically saving and storing energy for whenever you need it. That's what it does. So now that's another misconception too, y'all. So now the beautiful thing about this though is, in order to get this energy into the cell, you need glucose, because what insulin does, takes the glucose that you get from your meats and that you get from your vegetables, and it takes it to the cellular wall, and insulin penetrates the cellular wall, and it literally drops off these sugars inside of the blood. Well, guess what you don't need insulin for? Whenever you eating your fructose don't need sugar. Fructose don't need insulin. What fructose goes through a metabolic process that's called cellular infusion. What fructose does is it infuses itself into the cell. It's a big difference. So when you eating fruits, you don't even need the pancreas, because the fruit is going to literally infuse itself into the cell. When you eating vegetables and you eating meat and you eating grains and stuff like that, you need insulin, because that's the only way that it can get glucose into the cell. You see that? There's a big difference. So fructose, you do not need insulin, which means you don't need the pancreas. Glucose, you need the pancreas because you need insulin. If y'all got that so far, type in some nines. If y'all got that so far, type in some nines. So fructose, with fructose sugar, monosaccharides, you do not need insulin. The metabolic process literally called cellular infusion is when the fructose sugar infuses itself into the cell. But with glucose, you most definitely need insulin, because insulin takes glucose and it penetrates the Golgi apparatus of the cell, because it fuses itself with cellulose, which surrounds the cellular wall of the cells. There's a big difference. So whenever you eating fruits, you don't need the pancreas. And that's the reason why we healing so many diabetes cases when we put them on all fruit diets, because we give the pancreas a rest and we can cleanse out all the mucus that's built up inside the pancreas. We can cleanse out all the acids that's built up inside the pancreas, because we don't need to use the pancreas because we're using fruits. I can bypass the pancreas now because I don't need glycogen, nor do I need insulin. Because fruit don't need either or to make it to the cell, because fructose go through something called cellular infusion. So you have people that don't know what the hell they be talking about, saying that fruits causes diabetes. Fruits raises the blood sugar. No, the fuck it don't. Now, would it spike it just a little bit for like a couple of hours? The most I seen it spiked it for 2 days. But after that, it regulates itself, because guess what it don't need? It don't need glycogen, nor do it need insulin to make it inside the cell. It go through something called cellular effusion. Just like the rain in the clouds absorbs rain and then it makes it rain, your cells do the same thing when it comes to fructose. It absorbs the fructose sugar. It absorbs the monosaccharides. It absorbs the disaccharides. It kicks out the polysaccharides. It kicks out the sucrose. And you need insulin for that, because these are heavy complex sugars. It needs more to make it inside the cell. So what insulin does is penetrate the cells, and then it brings in all the complex sugars in. If you're dealing with simple sugars like monosaccharides and disaccharides, then that can be infused in the cell, and you don't even need the pancreas. So now we can allow the pancreas to actually rest and heal itself, and we can pull out all the acids, we can pull out all that mucosa membrane response from it, and we can allow the pancreas to resurrect itself. Now, another thing we have to talk about too that's very deep, y'all.